Hello, my name is Renee Oshop. I'm an astrologer and researcher in Boulder, Colorado in the United States. I came across a strange anomaly that I'd like to share with you. I use Mathematica for most of my coding projects. Besides math, it supplies many secondary tools, one of which is an events database, providing a start date and a short description for almost 8,000 events, which is probably not too many in the big picture. A word cloud of the descriptions shows the most common words. Actually, this is constrained in two important ways. One was that I only included the 7,153 events that began at or after January 1st, 1600 AD, so that events with earlier Julian dates would not be included. Secondly, I removed numerals so that, for example, the Battle of 1812 would become the Battle of. I want to check for an association between these short descriptions and the astrology charts for the dates for the events they describe. This is why I want to remove numbers in the descriptions. For example, two events described as occurring in 1812 would de facto have similar descriptions and similar charts, so I want to avoid that artifact. The number of pairs of the 7,153 events was a simple combinatorial of that number take 2, resulting in over 25 million pairs. To measure similarities in the text descriptions of each pair, the scalar dot product of the embeddings from the bidirectional encoder called BERT from Google was used. To measure similarities in the charts of the pairs, I used the scalar result of adding the cosines of the differences between the astrology placements for the Sun, the Moon, Mercury, Venus, Mars, Jupiter, Saturn, Neptune, Uranus, Pluto, North Lunar Node, and South Lunar Node. This resulted in a continuously defined single number that ranges from -12 for chart pairs that are all at 180 degrees across the 12 placements, through 0 for squares, all the way to +12 for conjunctions for the 12 placements. Early plot imagery of the two measurements suggests dependence but not monotonic correlation. The null hypothesis here, then, is that the measures of description similarity and of chart similarity have nothing to do with each other, that they are independent. I want to test the only alternative hypothesis, that the strict converse of the null hypothesis is true, that one is dependent on the other. One measurement is dependent on the other measurement. Because demonstration of correlative monotonicity is not desired, but showing dependence is, I used the appropriate Hoeffding's independence test. This is an integral-based statistic that uses ranked values, sort of like Spearman's rank does. Calculating the statistic for the full dataset was prohibitively expensive computationally. The calculation was aborted after 6 days, so a p-hat upper value for the p-value was calculated instead. The approach is simple. Use a Monte Carlo resampling of 1 million random pairs done 100 times. The upper bound for the p-value is then simply r plus 1 divided by 100 plus 1, where r is the number of samplings with a higher p-value than the culturally accepted one for significance of 0.05. In fact, no resampling out of the 100 resulted in such a p-value. In fact, they were all so infinitesimally small, they were smaller than the chance of you reaching out your hand and grabbing one particular random electron out of all the electrons in the universe. Thus, the p-hat upper bound for the p-value here is simply 1 divided by 101, which is less than 0.01. So in this study, the null hypothesis of independence turns out to be statistically extremely unlikely. Therefore, the strict converse is implied, that one measurement is dependent on the other. Use this QR code to access references and the full calculations, including that for generation of data. Thank you.